Alrighty, let's do some linear programming. There's a lot of vocab in linear programming. What we're trying to do here is maximize the objective function. So we've got ourselves an objective function, we've got ourselves some constraints. What I've done is I've already graphed our constraints, and I'll show you where the overlap is. So when you graph your constraints, you should see this. All we care about is this part where all four of these overlap. I've already shaded that. We call that the feasible region. Now, since that's all we care about, I'm going to go ahead and take that, and maybe I'm going to copy that. I'm going to copy that back into what we're working with so I don't have to keep flipping between these two things. Ooh, that was fancy. Okay, so let's go back, and now we've got ourselves a graph. What I'm going to do with this graph is I'm going to test the vertices. The vertices in this graph are right here, right here, right here, and right here. And there's a rule that says if you test these points, the highest value you can get and the lowest value you can get will be at one of these vertices. So what I'm going to do is test all of these different vertices. I'm going to do 6 times x is 2 plus 5 times y is 7. I'm going to do the same thing for all of them. 6 times 3 plus 5 times 7. 6 times 6 plus 5 times 4, and 6 times 2 plus 5 times 0. The fundamental theorem of linear programming says the maximum and minimum will be at these vertices. These are the intersection points on my overlap. So that's 12 plus 35, so 47. 18 and 35. 18 and 35 is going to be, 53. So there's 53. 36 and 20 is going to give me 56, and then down here 12 and 0 is just going to be 12. So if I said what's the maximum, which one's the biggest? 57, 47, 53, 50, 56 is the maximum, and where's the minimum? There's the minimum. So I say the max at 56, the min would be 12, and we're done.